In this video, I'm going to run through the answers to the exam questions at the end of 6.2. I'm not going to do question 1 because it's there for you in the mark scheme, but I will do the multiple choice questions. So question 2 asks you which molecule is non-polar. Okay, so in the first molecule, I've got sulfur bonding to fluorine. I do have polar bonds, but do I have perfect symmetry? There are 6 bond pairs around sulfur. That means the shape is octahedral. All of the bonds are the same. Octahedral is symmetrical shape. So if I've got polar bonds, but I've got perfect symmetry, they will cancel out. Those dipoles will cancel out, and overall, the molecule will be non-polar. So my first instinct is the answer is going to be A. I'm going to go through the other molecules as well. And the next one, H2S, I have a polar bond. It's not very polar. There's not much difference between sulfur and hydrogen, but it is still counted as polar. So I've got a polar bond between sulfur and hydrogen. Do I have perfect symmetry? I've got 2 bond pairs and 2 lone pairs around sulfur. That means that the shape is non-linear. Non-linear is not symmetrical. So I do have polar bonds. I do not have symmetry. The dipoles do not cancel, and overall it is polar. PF3, again, I've got polar bonds. There is a difference between phosphorus and fluorine. I've got polar bonds. Do I have symmetry? I've got 3 bond pairs and 1 lone pair. The shape would be pyramidal. Pyramidal is not a symmetrical shape. So yes, I've got polar bonds, but no, I do not have symmetry. The dipoles do not cancel, and overall it is polar. The next one's going to be the same. I've got polar bonds. It's trigonal pyramidal, which is not symmetrical. The dipoles don't cancel, and it is polar. So my first instinct of A is correct. The next one, which molecule is polar? So again, I've drawn them all out. I'm going to start here with carbon. I've got carbon-hydrogen bonds. Carbon-hydrogen bonds are not polar, so I'm not even going to bother working out the shape. Straight away, I'm just going to say this is not polar because there's not an electronegativity difference between carbon and hydrogen. I can do the same with the next molecule. It's not polar. I don't have an electronegativity difference. And the next one, I do between carbon and chlorine. So even having 1 polar bond is enough to consider it. So I do have a polar bond. Do I have perfect symmetry? I've got 4 bond pairs surrounding carbon. The shape is tetrahedral. Tetrahedral is a symmetrical shape, but not all of the bonds are the same, and I do not have perfect symmetry. Without perfect symmetry, the dipole do not cancel, meaning I do have a polar molecule overall. The next one, I've got more polar bonds. So you might look at this one and think, right, I've got 4 polar bonds compared to 1. Surely this is my polar molecule, okay? Yes, you've got more polar bonds, but you've also got perfect symmetry. It's tetrahedral in shape because you've got 4 bond pairs. Tetrahedral is a symmetrical shape and all of the bonds are exactly the same. So yes, you've got 4 polar bonds, but they're acting in opposite directions. Because you've got perfect symmetry, they cancel each other out, and it's actually non-polar despite having more polar bonds. So your answer is going to be C, purely because the 1 polar bond isn't cancelled because you don't have symmetry. The last one, which compound has polar molecules? Again, I've drawn them out. So the first one here is oxygen bonded to 2 chlorines. I do have polar bonds. There's an electronegativity difference between oxygen and chlorine. Oxygen's got 2 bond pairs and 2 lone pairs. The shape is non-linear. Non-linear is not a symmetrical shape. Therefore, the dipoles do not cancel, and I do have a polar molecule. So I'm thinking A for question 4. The next one, B. There's no bond pairs around boron. Okay, it's in group 3. It's only got 3 outer shell electrons, and it's using all of those electrons to form bonds with chlorines. So I've got 3 bond pairs. That means my shape is trigonal planar. Trigonal planar is a symmetrical shape. So yes, I've got polar bonds, but all of the dipoles cancel because I've got symmetry. Therefore, it's non-polar overall. Carbon-chlorine, we've seen this one above. Yes, you've got polar bonds, but you've got perfect symmetry. Tetrahedral is symmetrical, all the bonds are the same, the dipoles end up cancelling, non-polar overall. The last one, sulfur bonded to chlorine. Yes, I've got polar bonds. The shape is octahedral, 6 bond pairs is octahedral. Octahedral is a symmetrical shape. All of the bonds are the same, so I've got 6 polar bonds, but they cancel each other out. Overall, it's not polar, and my answer is, as I thought, A. So you need to know your shapes, and you need to know which ones are symmetrical, okay? The symmetrical shapes are the ones that don't have lone pairs around the central atom. So linear, trigonal planar, tetrahedral, and octahedral. The non-symmetrical shapes are the two that do have lone pairs, so pyramidal and non-linear. The other thing to look out for in terms of symmetry is, are all the bonds the same?